Hello there! Welcome to openEuler Certified Associate Courses. Today's course is all about getting you up to speed on the key concepts and essential operations of openEuler process management. So let's dive right in. Before we begin, let me clarify the concept of a process. In a computer system, a process is an instance of a running program and represents its execution. When a program is loaded into memory by the system, it is allocated a set of resources, such as memory and devices, and undergoes a series of complex operations to become a process that can be called by the system. A process comprises not only the program's static code in text form, but a heap, a stack, and the various data segments. The heap is used for dynamic memory allocation throughout the execution of a process. The stack primarily serves as a repository for temporary data, such as function parameters, return addresses, and local variables. And the data segment is utilized to store initialized variables. In Linux, a process can exist in one of the 5 statuses: task running, task interruptible, task uninterruptible, task zombie, and task stopped. Task running indicates that a process is running or waiting your running queue. Task interruptible indicates that a process is sleeping, blocked, or waiting for a condition to be met or a signal to be received. Task uninterruptible indicates that a process does not wake up and cannot run after receiving the corresponding signal, but must wait for an interrupt to occur. Task zombie indicates a zombie process that occurs when a child process terminates before its parent process, and the parent process fails to properly release the resources of the child process. Task stopped indicates that a process stops running after receiving the stop signal. So, how can we query the information of a process? There are 2 commands that can be used. The first is the ps command, a fundamental and powerful command for viewing processes. With this command, you can identify which processes are currently running, whether a process has completed, whether there are any zombie processes, which processes are consuming excessive resources, and more. You can obtain most process information using this command. This is an example ps command that queries all running processes on terminal. The ps command offers a variety of options, each with a unique function. For example, the E option displays all processes, and the X option displays processes that do not have a controlling terminal. The other command used to query process information is the top command. The fundamental functions of the top and ps commands are identical, as both are used to display the current processes and corresponding statuses in a system. The top command, however, is a dynamic display process, which means that the current status of a process can be refreshed continuously through key press inputs. If you run the top command in the foreground, it will occupy the foreground exclusively until you terminate the program. Here's an example of the output of the top command. To terminate a foreground process, you can simply press Ctrl C. However, if you need to terminate a background process, this method may not work. In this case, you can use the kill command, as it terminates both the foreground and background processes. Reasons for terminating background processes may include excessive CPU usage and deadlocks. The kill command has 2 syntax formats, as you can see on this slide. Both involve a signal, because the kill command terminates the process by sending a specified signal to it. If no signal is specified, the default signal term is used. The term signal will terminate all processes that cannot catch it, while processes that can catch the term signal may require the use of the uncatchable kill signal. Sending the signals requires the current user to be either the process owner or a root user. In addition to the term and kill signals, the kill command also has many other signals, such as exit, hop, int, and quit. You can see this table for more details. I just mentioned foreground and background processes, but do you know what they are and how they differ? A foreground process interacts with the user and requires a high response speed with high priority. It has a controlling terminal and receives a larger share of the system resources. A background process has little to no user interaction and is low priority. The daemon of Linux is a special background process that is independent of the terminal and periodically executes tasks or waits to be woken up. OpenEuler uses many commands to manage foreground and background processes. Adding the ampersand sign to the end of each command can run the command in the background. When a process is being executed in the foreground, pressing Ctrl-Z can push it to the background and pause it. Pressing Ctrl-C can interrupt a process that is being executed. Running the jobs command allows you to check how many processes are currently running in the background. Running the fg command can bring background processes to the foreground, and running the bg command can wake up background tasks and run them in the background. Next, I will discuss the sequence in which a process is executed by the CPU, known as process priority. The execution of a high priority process will be given precedence over low priority processes. You can run a ps command to view the priority of a process. Here's an example output, where the read PRI and NI fields are related to process priority. PRI is the process priority value, and the lower value indicates higher priority. NI indicates the next value. It is the corrected process priority value that ranges from -20 to 19. A process with a higher next value will be less likely to be scheduled for execution when the system is busy, while a process with a lower next value will be given more priority. Processes with PRI values between 0 and 99 are classified as real-time processes, whereas those with PRI values between 100 and 139 are classified as non-real-time processes. Now let's learn about Cron, a daemon or background process in Linux systems that executes commands or specified programs periodically. Cron checks whether there are tasks or jobs to be executed every minute, and if there are, it automatically executes them. Cron manages tasks or jobs using the cron tab file. You can input the commands that need to be executed and the time when they should be executed into the file to implement scheduled task or job execution. Each line in the file consists of 6 fields, with the first 5 fields indicating the time of command execution and the last field specifying the commands to be executed. These fields are separated by either spaces or type characters. The configuration format is minute, hour, day of month, month of year, day of week commands. The meaning of each field is clear, and you can refer to this table for details. And that's all for today's course. We hope you found it useful, and if you did, remember to follow us on social media accounts to keep up to date with future courses. Join us in our community discussions or reach out to us if you have any questions. Thank you for watching, and we look forward to seeing you next time.